Another method of separation is crystallization. Like we said, that for salts that are affected by heat, we can't use evaporation to separate them from their solution. Rather, we do crystallization. The process is almost similar. The only difference is that evaporation to dryness, we are applying heat to the solution until the water in the solution dries up, leaving the salt behind. Crystallization is a little, but not until the whole water dries up. Now, how do we do that? This is a container containing the salt solution. Here's my salt solution. My salt solution is right there. It's a concentrated salt solution. Because this salt in here is affected by heat, I cannot use what? Evaporation to dry it. Rather, I use crystallization. Now, what I do is to heat up this salt a little and then remove it from the source of heat and allow it to cool. As it cools down, crystals of salt will be forming out in this solution. And to speed the rate of crystallization, there are things we can do. And those things are what? You can either scratch this to act as a center of crystallization or adding a sample of the salt into the solution, which we call seeding. That is, seeding is what? Adding a little crystal of the salt into the solution to speed up the rate of crystallization. Now, examples of salt that are separated using this method are copper 2 sulfates, and copper 2 tetrahydrosulfate 6 pentahydrate, and copper 2 triethylnitrate 5 trihydrate, and iron 2 tetrahydrosulfate 6 heptahydrate. So we cannot separate them by evaporation to dryness. Rather, we use crystallization. Again, I have a simulation for that. So let's watch it and see what happens. Okay. Again, we place the container containing the salt to be separated. This is a solution of the salt. And so salt solution set on water bath. We place it inside water bath, but yeah, place it on top because this container is bigger than it, clearly. As I have to place it on, and then the heat is transferred to the salt solution on top. Look at it. We heat it for some time. Remember, it's not evaporation to dryness we are doing it. We just want to heat up this salt to kind of saturate the solution. Because if you heat it to evaporation to dryness, the salt inside is affected by heat. It will be decomposed. And we don't want to decompose the salt. We just want to remove the water or remove the salt rather from the water. So we heat it up to saturate it. Look at it. Salt solution is allowed to heat up for a while. Then we remove it after it's heated. Okay. Now we have removed the salt solution from the source of heat and we allow it to cool. Now, as it cools, you see that crystals of salt will be forming. You see, crystal of salt is being formed, and crystals of salt is being formed as it cools. Now, that is crystal formation. There are two things we can do. Either seeding, that is adding, if you have already the crystal of this salt available, you have it, you can add a little of it into it. As the water cools, just add a little of the crystal of salt into it. That practice is called seeding. You are adding a seed of the salt into the solution, or you scratch the inner surface of the container. Now, I decided to use a glass container here. It's not glass we use in the lab. There is a special thing used for this, a ceramic plate actually. I just want us to be able to see through what is happening. That's why I decided to use a glass here. Okay, so look at it. You see the crystals of salt is already formed. So we can have use filtration to remove the crystal of salt, which we already described. We described that filtration as a method of separation in the previous one. So just pour this water now with the crystal into filter paper, of course. The water will pass through, leaving the crystals on the filter paper. You can now dry the crystal in a desiccator.